Yeah, setting up, changing color a bit. So it's easier for you to watch. Right. See if this is visible. Hold it around a bit. So. Okay. Turning down the ocean loader. So there we go. So in the last stream, I made it. I was refactoring this, like putting the contracts separately, and I just wanted it to work as before. So now that we have that, we can start looking at something else. Namely, we can start taking this one and then separating these parts of the contracts, so we no longer need to iterate over everyone, every single one of them every time. Okay, so we are here, and let's just look at where we were adding these. So they are added. Not there. We are going to add them. Parsing. That was not the one I was looking for. But okay. So we're gonna parse contracts. There we go. Oh. So here we parse the contracts, right? We did this thing here. So we could have just maybe no. So and we will get like the return one is separate, right? So we will get one or more of these opt returns, right? What we want to do is like basically, let's see here. So there's the return, right? And there's the return question. So the return question is the one with the opt returns. And if we get a direct comment on this, we don't store that. We just poof, throw it away. But if it's an opt return, we do it differently. So what we can do here is we can take, like here is actually correct, right? So we want to take docs and the docs next. So in this case, though, we want to add another one. So we have the first, right? So we want to have instead the ASTID, which would be opt contracts, opt returns. So now we will get all the opt returns in that. So instead we have like first, now we have another one which is not first. It's going to be like actually we can just pull that out of this. So we have the next AST ID next hey, hang we can, oh yeah, that's better like this. So next contract. But however, the opt contract is just a list. If I recall correctly, this one is just a list of oh no, it's a bit more complicated, right? So let me see. Where do I at? Opt contract, opt return, opt contract, opt something. Did I manage to jump somewhere else? Okay, opt return. So it's going to be like a contract fault, and that one has an expression, and there's this thing which is the comment, and then we have like these fault, and this is just a list of expressions, really, right? There is no need to handle them separately. We can just pass in an expression. So we can just have an expression list. So instead of this, we just do expr, and that's like this opt returns. So that means when we get to this point here, like we can just I've gone blind. I'm just not seeing this every time. I just forget where it is. Okay, so not first, but we get like the opt returns and the reference to that. So people who are scared of stars, I don't look at this. So return ref. So that's a 3-star thing. Okay, so here we go. We're going to add those to the returns, but we don't need that anymore, right? So we don't even need, look at this. We create the contract fault, now we create this one, so we actually don't need that either. So instead we have like expression, expr, and then we just like add return ref with expression. That means we don't need this, we don't need this, we don't need this, we don't need this. We skip that, and we don't need this, we don't need this. But obviously that means also, so AST, now when we're copying this, where is it? AST copy, no, declare copy, copy, let's do a bit like this. So we have this one and we copy it someplace. JSON, but not that one. Copy. Okay. So now we also want to copy. So copy, microcopy expr list. Copy contracts, and then we have this returns. So now we no longer want this AST node that we had from before, which was like this opt thing. So you have contracts. So in the contract fault, we have that one, right? That was the one that I was using before, yeah. So we're going to remove that. Okay, that means there's no codegen for it. There is no copying it. Oh, okay, so we're going from like decals to expressions, right? We should have like it shouldn't be like, depending on whether it's resolved or not, we should do it differently. Okay, so that's important. So we have the contract fault. So rather than having that, we need the returns there. So if copy is resolved, status is resolved done, then we're instead copying a declaration list. Then we have union the decal of returns resolved. Opt return resolved. Otherwise, we do this. So we have the copying there. We can now remote. Okay, we haven't fixed up in decals, yeah. So actually, it's going to do that, right? Yeah, it should be doing that. Blah blah blah. And this means this cogen. For that, it's also gone, right? And this contract can't have this. Sim aliveness. So we don't have that. Then sim statements, it also doesn't have this. Okay, but we do want to that's odd though. Okay, yeah, breaking this. This is not right, by the way. Okay. Oh god. You're also an online lecture. Don't listen to me. Okay. Right. So let's see here. Okay, it kind of crashed, which would make perfect sense, by the way. So we want information. Let's see here. So we're gonna handle that. We are removing that. We omit the docs here. What is this? Right. Cogen. Where are these? We are going to add those directives, but why are they not in the return? Why is this compiling? That shouldn't be compiling. Maybe I should store this before I continued, because it doesn't make sense that these contracts are still compiling for me, right? Maybe it's in doc header. So where did this? I killed this, right? This process, but why is it? Where is it stopping? Okay, where? Oh, it's actually outputting stuff. That's surprising. Let's just stop that one and run. I hope I didn't run into another problem. Let me look here. Okay. Right. Okay, so that one works, but the other doesn't. There should be this check for those, like okay, sorry, I'm like kind of want to see what happens now. Okay, so this is compiling. Oh no, it's stuck here. No. Do I just have happen to have okay backup daemon? Right. So my computer is running the backups. That's why. Almost done. Okay, so that's might be why it was so slow, but what's somewhat surprising is that I didn't get any errors. So let's see. We have the AST nodes. Maybe I just had the normal ones after all. So we have, right, these require contract optionals. What's that? Is that one? Maybe I didn't use it. Like maybe I never used it. Could it be like that? So contract optionals. Ah, okay. So I don't know. That's weird. I never used that other thing. So like, okay, maybe I should do that right now. Okay, we have this contract before, blah, 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 blah. And then here, contract has, okay, has any. So in order to do this, let's see what we have. So here we're going for the first, right? It's just looking for anything. And then we can have like, we are not storing the span of the first thing. Should we be running this? Question is, should we be running this? We should maybe store the first span of the first thing. Then we can also always, let's do it like this. So contract as any, that means anything but comment, right? So that's all it wanted to show you. That means we can look at that thing and then have a look at the span here. So here you go. Here we set the span to there, but once we like have this, if not contracts, else if not first, then in that case we can set also like update the span of that particular AST declaration. So the span actually matches the contracts. Span equals let's see, span. So this updates it, so when we do them error returns, then we can when we want error because there are contracts but not just, it's not yet comments, then we can just use this span basically. Okay, so AFC contract has any, that one can be removed. No, because it can just do like something like contracts if contracts first or contracts decal returns. In that case we can print this. I should end up in the right place. Right. Oh, we can retain that. So we're just going to have a return a bool instead. And that's going to mess up a few things, but and then we're going to take a decal. and it's going to be not AST, it's going to be Decal contract as any. So Decal, and it's that. Bah. If contracts and contracts and contracts first or contracts, and then we had this okay, blah. I'll add it for the other one. Right. So it's true if that is true. Now it doesn't return anything useful. But we use it. So if Decal contracts as any contracts, and then we're fine, we can print this error. So AST contracts has non-require, any non-require, okay. Then we just change this to again this. We are going to improve this later as well. Decal. So if not contracts false, right, and then we have AST ID first, then if contracts opt returns, then we return true. Well, then otherwise we go and just go through these docs equals contracts. It's going to do this. Okay, apparently like this. No. What? Okay. Okay, everything was right. So contract comment should never happen again. Like this is not possible. Contract optionals is also going away. So goodbye. Right. And it's returning that one. Okay, so it's returning that particular contract. How do I store that then? There are no usages of it. Okay, but we can do it like, actually that's possible. We can have like the source for that. Now I'm just hacking things a bit. Oh wait, is this used anywhere? Like if it's just used here, there is no need to do it in any complex way. Find it plus AST contract. Because if it's just used there, right, then contract has any non-require. Let's see if searching works. No, it's I'm searching in the test. I thought it was strange. So there's a use here and declaration here, and then there's this, and then there's this also. So it's, you know, it's just used in this particular case, right? So then we can look at like if contracts contract equal returns. I think this is just for like okay, so then ASTID, then we have to inline this thing for now. Okay. So this sucks, but it will go away later. So we are going through these. So we have the contracts. We go through these while we have them. If we have one of those, and just okay, yeah, I'm improving contracts. Hang on, I just got a my kid. I'll be back. I'll be back. Oops, there we go. Right. Yeah, not just like improving contracts, but it's like it's not really doing anything special, right? It's just improving how it's stored because it's kind of weird right now. Okay, so I'm just changing how these are handled. So store it better. So now we got like contracts, blah blah blah, and next and so on. Yeah, whatever. So we're moving around these returns right now. So these are the ones that should be different for now. So we get the optionals, right? Hang on, what's this? Docs faults, right? Oh, so they are AST nodes. Yeah, okay, they're AST nodes with the faults, right? So like that. So they go gone, right? And the comments are not there, so they are also gone. And the contract comment is like what? Emit docs, right? So the JSON output. If true, I mean, I don't want true return false. This is just broken right now. So the comment, I mean, maybe I can just do it. If AST contract, it's like, so we get the contract as first, blah blah. It doesn't matter. If it doesn't, no. If contract, contractual comment. If not, just return. Otherwise, we do return that comment. It's like blah blah blah. AST, no, contract stackle. Comment length. Comment. And then they're done, right? Okay. Let's see what the next place is with bad things. Okay. So we have a contract comment there. Oh, parse element contract. Okay, if it's, and we start parsing the contract, and then we'll look if no constraints are allowed on blah blah blah. Okay, so then we can basically say there if there are no, okay, so if there are is one, right? So we have one, then we can just what's this? Parse element contract. Okay, so the bit struct member, false, and so on. They can't have. Okay. If so, it's like this. If we have this, maybe you have that. If decal has any non-require, has any. And then we go for the contracts. If it doesn't have that, then we're fine. Otherwise, we're going to return print error at false, comma, and the contracts, which is going to be like the correct place. So also shorter, right? Okay, let's continue. Okay, what's this? Okay, then the default. So we're gonna analyze this. Okay, wait, it's an oh, so it's not just damn it. So it's not just, okay, we have resolved expanding on different, okay? So we either have, and how do we like decide that it's expanding? Like how do we see that? We are analyzing the expression, right? Yes. And oh, here we go. We get the expressions, right? So if contracts, like if we don't have contracts, okay, let's continue, right? Then we have decal contracts, so pointer of contracts. So if we don't have any returns, then we can continue. Then they just loop. Okay, so we have like expanding. While it is expanding, we are we're setting a flag here. How do I use this expanding thing? Okay, so I don't want to resolve it twice, basically. Then we can set that as a flag here, I think. Is expanding. Returns. Okay. I would say okay, so these should be, yeah. This should never happen if directive if it's, I mean, it should be, okay, so expanding is essentially same as resolving, so why do I have AST? That should be it. Okay, let's see here. So we're assuming that this one is running multiple times, right? It's not super much, but it's enough to be a bit weird. I wonder if this sets the running, not running. No, it doesn't. So we shouldn't analyze this if we have like if contracts resolve status is resolved done, then we just return true. If contracts resolve status equals resolve running, we just return true. It's not, so this one is a bit different. So not done. Then return true. Otherwise, we are going into this. We're going to do the optional returns first. Oh, we're going to say contracts resolve status equals resolve running. And then here we're going to go to fail. I'll put that bottom here. So it's fail. That means we're going to set this contracts to resolve status equals resolve done. Return false. We're just going to return false once on these contracts, on the same contracts. Okay, so if we have a contract, then we have a lot of these, or one more of these. Expert contracts, contract decals, opt returns. And then we're just going to go for this, and we're gonna assert here that contracts resolve status is not resolved done. So then we have a bunch of these. Okay. Now we're going to have like resolve. So as you see, we are then analyzing that decal, contract ready, blah, blah, blah. I don't know what this is doing. Okay. Let's see. We have a declaration. I kind of broke the thing before, so we have a declaration. That one could have one of these set of things as well. So you're going to sub contracts. If not, then we can just continue. Otherwise, we need to like also resolve those, I guess, but only their optionals. If the contracts is like resolve status equals resolve. Oh, we can switch over that. Switch. You see the problem I just created here? We have fail, then we should say like contracts. Also defaults in this one needs to be 0. Oops. Op returns must be null. Op returns result should be null, right? So if you go here, you get the first resolve those, then you start resolving these properties, la la la, and the modifiers and so on. And then we go back and do these optional returns. So we try to figure out what the declaration is. Maybe this is something that needs to be expanded. In that case, we do look at the state here. So if it's contracts resolve status equals, oh no, I put the resolve status early, right? The contracts, the op returns should only be it's kind of tied to those contracts, right? So dum. I'm confused, making myself confused here. So I think we are going to do like this. Those are not going to, it's going to be like, if it's not done, if it's not done, it's okay. Otherwise, it sets itself to resolve running, and we are not going to modify this here. We're not going to use fail either. Okay. So instead, we're going here, and now we can look at this. You can set the we set it to resolve running, right? And here we do have to have a go to fail. So fail. In case we fail, then we set the contracts to resolve status equals resolve status done. Then we set the contracts contract tickle op returns resolved to null, so we no longer have any. And then return false. Okay, good. So we go here, and if it's done, we're done. Then we start trying to create the new ones, right? So we go in here to the expression. If it's an identifier, blah blah, we're kind of done. Type info, like it's fault, right? And here we're going to go like sema is default, and then we go to fail, right? Right, we have to look at that at every place. So here, if it's a rethrow expression, we can't do it, then we go to fail. I think this is for the expression. This is for expanding things, right? The type has something, la. By default is fault. Okay. So now here we are looking at those subcontracts, and if it doesn't have any returns at all, we just continue. Then we switch on the status of those subcontracts instead. Sorry, that was wrong. So we switch on that status, So we have resolve done. We have a case resolve not done. Oh, and we have a case resolve running, right? So if it's not done, if it's done, then we're okay. If it's not done, or it is, and if it's running, then we can, that's a circular thing and we want to continue resolving it. But if it's not done, then we want to do like if sigma analyze optional returns, analyze optional returns, there we go, returns for there's contract and these subcontracts. If it's not, it fails. Let me go to fail. Right, do we have any other failure here? No, it's fault. Oh, here, go to fail. Go to fail. Failed. Fail. Right. Go to is fault. Right, those are fine. So we only have those possibilities, and then it kind of goes through and tries to expand, and we already did that in line, so we're fine with that. And then we continue, apparently. What happens next? So let's see here. So we get a declaration. What did this look like before? Let's look at the original, because I don't remember. I feel like it should be adding those declarations, right? It should be adding that here. So let's have a look at this code before I started changing this. Okay, so show history for selection, maybe. Now you don't see this, but I can kind of look at how it changed. So before this, it was analyzing that the docs and that was enough, apparently. Okay, so maybe I just need to do that. So this is just recursively trying to fix the other things, right? So we are in here again. So when we have this declaration here, end up with a declaration, right? And then we do get like big add. And then this decal to the contracts, the decals, decal, right? And then we are almost done. We have a bunch of things that we need to fix though. So result, okay, result. Great name. So result. Then when we're finally done, we can set, you know, the contracts to result status is done. And then we update those contracts. Oh, thank you for that random insert. This will look nicer, by the way, later. It's just right now it looks a bit bad. Okay, so let's see where we can, if we can find something else that's doing something wrong. We should have like a return blah 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 somewhere. I know I saw it. So okay, here go to fail. Right here we need to go to fail as well. Go to fail. Failee. And then here, if there's not a declaration, there, then go to fail. Now we just start. Okay, so that looks okay. Now let's look at the other things that were broken from this. Okay, maybe I can just run this. Oh, okay. Thought it looked like your editor were full of errors, but no, it's just please tab visual. Yeah, otherwise I don't see that. Is C3 written in C and not C3? Yes. Why self-host? It's just taking time. Okay, he skipped that one because that can never happen again now anymore. So let's do it. Here we go. Okay, so go to fail up here. No, it cannot. So it just will just return false. Now we need for the old behavior. Oh, now we go. Here we go. So we're going to analyze the optional returns. Okay, so it's just going to go through like where is that called? Oh, no, sorry. Here I analyze the optional returns, of course. We don't analyze contracts, right? Who does which one does this? Okay, so analyze contracts. And then we should just pull out the contracts themselves, I guess. Now the returns are gnarly because of the way it they want to be copied basically for macros. I don't know. I need to look at. I need to change a lot of things, so I might be more things. So here we are analyzing the contracts. We need to do the comment goes away. Optionals. So F has insurers. Not if it doesn't have insurers, then we skip. Okay, we skip that. If it has insurers, in that case we want to what? We want to analyze optional returns. Right, and we have the directive, which is the one actually, damn it. I do that copying thing. Maybe I should just change this. So it takes, where are we? Should probably take those are the asserts, right? The resulting asserts, but we have like a Yahoo. Okay, so decal is the false. No. Let's do it like contracts. If as ensures, then we do it from the contract. Analyze optional returns from a directive. No, okay, that's a different thing. Okay, I was confused there. So this thing, this is adding those contracts basically, and only if it has insurers, then it will add it to the, or it actually will it update that one? Right, so we get a bunch of optional returns from the contract. Maybe from the contract. Right? So this from there we go. So take all contract. Right. So there are so many things that will be like different. So it's a bit like jump back and forth and maybe hard to follow. So if there are no contracts, no faults, if that one is empty, then we just return true. Just works. Otherwise, look at this. Does this again? Or was that one? No, that's another one. Anyway, just gonna grab some tea. And oh no, I have actually four. Then I just go for a toilet break. Second. Like just the fact that was so hard to pry these apart just shows that it was needed. So okay, so in this case we want to Sima analyze. What's the name of it? Analyze optional returns, right? So we're gonna make this instead of static here. We need to have this from outside. We need to do this on demand, actually. But the question is, like, shouldn't? No, it's not certain that this is already available when you are resolving a statement. Actually, I was thinking that maybe you should always know this, but no, you don't. So we have to pull this up here in the compiler. Internal semantic internal. So internal. So up here, you need to know about this function. Now they are kind of, ordering and stuff is not good right now. Just have to go through them every now and then and just fix that. Okay, so we don't have that. Instead we need to, we can analyze it. Sima analyze. So we have like, no, that's not optional returns. What did you call it? Or is it called optional returns here too? Analyze optional returns and then it takes it to contract. Yeah, great, great name here. So call. We have to change that to something else. So like call optional returns, right? Analyze. So we got the overlapping names there. So let's see how we actually do it. So here in statements, that's what goes confusing me. Call and here too, right? Analyze call, right? Returns. Okay, and so here we go. In there, here we are basically we are adding like these to the opt returns for the call environment. Now the question is, can't we just set that since we know what the opt returns are? I think we can do, we can like set the call environment and then say like the opt returns returns are this and that. So like here, so basically even simpler. So this is like resolving things, right? So we have two cases. So maybe there are no returns. In that case, it's simple. We are just going to set the call environment returns to null. And we're going to return true. Otherwise, we have two things we need to do. Oh, otherwise, we need to do something else. If not, sigma analyze optional returns contract. Then we have an error. False. Otherwise, we set context call and opt returns to this contract returns resolved, right? But I need to know that how it uses this one so that it's not adding to it. So it's adding to it here. Oh yeah, it's just doing that in this one, this long call thing. So it's shorter now. Because in here we are just like looking at them, yeah. Contract comment is not something we use. Contract ordinals not one we use. So analyze contracts. Now we have the contracts. We need to have this. Shouldn't that be right? Contracts. Are we having more contracts than this? Okay, we have it here. Okay. Let's do it like this. It's an ID. Now we can use this one. And the contract. Analyze contracts. So get contracts. Okay, docs is up here. That means here contracts. Right. So let's see. Analyze contracts, right? As ensures. Okay, it doesn't. Okay, it sets it to 0. No, then wait. Okay, but if we don't have a contract, then this should work. Okay, so if not contract or SIB contract. Okay. I guess some left already. Borrow check, by the way. Was shocked that we didn't write C3 in C3. But that's the way it is. So line 384. Let me look at that line just in case I missed something. Right now. Oh wait, was that in which one? Which file was that? Okay, maybe it's in here. 380. No, that was not it. Here, right. Let's see if I forgot something. Yeah, go to no, that's the header. So in here, let's see. Again, option. So return true, that's fine. Go to fail. Go to is fault. That's fine. Is fault. Go to fail. Go to continue. Go to fail. Here's the return false. Yeah, this one should go to fail. I think that was one. Right. It's gonna be cleaned up later. This is not like best possible presentation. And we're not done yet. So these are the opt returns. Then we have like requires and ensures, and they should all be kind of like right now there's just this first, right? So it's just the first contain happens to contain both requires, it's going to contain like pure, it's going to take it's containing deprecated and so on. So here we have some warnings, right? So what's that? Can be replaced by dot. Okay. What? Yes, it can certainly be replaced by dot. How did that happen? Like, how did these happen? That's something I would know. Okay. Boom, boom, boom. I get this. Rather, oops. That was in a different window there. So now I think like there are people running around in this. Here. Let me see if I continue streaming a bit more. It's getting darker outside. Maybe I have to turn on the lights. So it's a bit, I don't know. So the contracts are actually rather simple, but because of the way I implemented them, they ended up being complicated, right? Because I was thinking of like, yeah, we have like a list of these contracts, and it could be anything, and then we can look at that later, and it could be flexible. But then in the end, you just you just know what you have. You have your requires, you have your insurers, you have your pure and deprecated and such. So you don't need to do anything else. And like deprecated thing, that's also the thing that that's why I started looking at this basically. I hope I have some more tests that are actually breaking this, so that we can see that it works. So if I can just continue here. So we have like the contract params, right? So those are a list of like, they are actually something that should be attached to the parameters. So instead of having this thing attached to anything, it could be there. So let me look at like first pure, right? The contract pure. And so that's an annotation that you can get. So you can declare it there instead of on the function, and there's a reason for that. It's actually better to, in some ways, to kind of place it in okay, let's see here. So if we got the pure, right, attach contracts, right, or contracts, right. The pure thing, it just needs a place to live. So you know the span. So like you need to know there is a span for it. That takes actually some space. Why do I don't want to attach these contracts? Why do I need to do this later? Oh, okay, so I can do like this. All right. We can have the contracts, right? We can have it and then we can have like source span first non require, right? So if we have one, which we will have if we have opt returns, for example, we're going to set the first non-required to that. And because this one is set to 0 to begin with, it's kind of okay. Okay, so that's going to be much easier. So I have to do something where I add the opt returns though. So when I parse it, parse doc opt return, right? So here we go. If C no, let's do it like this. If contract first is non-require A. If it's not one, then we can set it. Stackable first non-required equals brief span Okay. And then we do the same thing here. And then we're going to do the same thing here. Actually, we should probably do it all together. Right, so if we have blah, 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 if here, set it. And then we move the whole, like, where is the require? Here's the require. Put that one on top, So like this. So then we need these, right? And then we go for here instead, contract first. Okay. I'm just gonna pause this so I can talk to my wife a bit. Where is it? So there we go. So let's get that first non-require. And then we're gonna print this invalid constraint. And then we are false. Right. That means we don't need to look for these either. Okay. So let's go back. I was removing the pure, I think, right? So pure is going to go into Boolean instead. So here you go, contract pure has any non-require, and then we know that immediately by saying like we do need this, like we don't need that. It's not used. Okay, it is gone. Okay, right. So there we go. Here's the contract pure. So like when we have this, we just say contract contract equal pure, and we can have multiple, I guess. Like, should we stop that or not? Pure. Let's see here. Okay, those are going to be like together, right? And then maybe, yeah, it's going to take up some more space, but pure equals true. This delay when you type is actually somewhat difficult. Right. Deprecated is not implemented as you see there, but we're going to have like, we're going to use this pure now and we have to implement that. So here we go. Okay, look, there's an already this multiple pure declarations, right? And there is like, okay, so we are going to go for, where was that? Parsing it. Pure, there we go. So if contracts pure, I can say not sim error, but print error here. Multiple pure, there we go. Once. So now that one is also checked. We don't need to handle this. Do we have the pure ref somewhere? Like, where is pure ref going? Okay, so okay, that's how it's the pure ref is just going upstairs. So multiple pure. So if you have pure before, I guess that I'll also do it. Pure ref. Okay, we don't have it there. Instead, it's here. So contracts as a pure ref. F contracts pure. Contracts decal pure. Then we set pure ref to pure. True. We can remove this one. Okay, then we continue. Okay, so okay, let me see here. So here for asking annoying questions again, you can totally ignore blah, blah, blah. What are your thoughts when compiler makes a decision for program when it pass to pass parameters by pointer and when to pass a value into the function? I've seen this in other new languages, but not the C3. I kind of like this. You kind of like when it does it for you, or you kind of like it, don't like it when it does it for you. I'm not sure what you mean. Which one do you mean, Nir? Or how I should pronounce that? Nir 24. You have to expand on what you mean by that. I know what you. I mean, I know the thing that you're talking about, but I don't know if you like it or not. I can tell you why I don't like it. Like it's only useful if you don't need to know what the API is, right? So C already has this in several APIs, right? So sometimes it will pass things by pointer and sometimes doesn't. I think maybe people don't know about this, but that's the way, like any larger struct will be passed by pointer. But what it does is like it usually makes a copy of that struct and then passes the pointer of that copy. Right? So it doesn't pass the pointer directly. So some languages have been like, I think Sig does this, and I think maybe Odin and Jai, because they are declaring that their parameters are immutable. Then they just say, okay, so it's always passed by pointer. And that's kind of okay, because then you always know. But it has some gnarly kind of changes. That means that if you are passing the same thing like by pointer and by reference and by constant, then you can get funny things that happen in Zig and so on. So like you pass if you have a like you don't need to have this that like decided to do this, just could just happen indirectly by some other function that you call, which is doing this. Or let's say you have a struct that is 30 um 30 ints long or something. You pass an array, and then you pass a pointer to that array, and then those are maybe some let's say a struct and a pointer to that struct, and then you mutate that struct using that pointer, and then you assume that the thing that you got by value is immutable, but it's changing under under the covers. That is kind of a problem that like any language that has problems with that. So it has to be very, very clear about these rules. I don't think Zig is clear about those rules. I think like Odin has some way to work around it. But the easiest way, like the thing is that C will pass it by pointer by doing a copy to something like locally and then create then a pointer to that. But that copy can be optimized away, so it will optimize away when it's safe to do so. Meaning that mostly it's going to work anyway, and the copy is not very costly anyway, but it's like very safe, and so it's funny when languages that are safe, like Zig is kind of funny at this. Like Zig's like, we are safe and whoa, but we still have this semantic bug that we can't fix in the language, which is like making things very, very unsafe to do. It's like this bug that you can like it's impossible for you to detect unless you understand that the kind of semantics allows this kind of aliasing. Oh, finally got an error. So okay, this doesn't match. Right, we have this. It doesn't match. Okay, so we have one bug here, right? In this contract copy opthread. So I have to look at this. Let's just see if we get some other errors as well. So I don't think it's worth it, because anytime you discover that a struct is too big to be passed, I want to pass it like by pointer because it's so big. Then you just do that. You don't need that optimization, because it's like when you discover that is a problem, then you fix it. So it's not to me, it's not a really big deal to fix. So okay, let's look at this. So another case that fails. Stuff. I think that we might have broken something else as well, but let's look at this one. So we're lacking a main method. So unless we have one, then this will be it will not accept it if I don't just do the running. So okay, so procedure parameters are mutable by default node, and if the procedure involves yeah, I know. So internally pointer, yeah. Yeah, exactly. So I know Odin does this. So but I think Odin does this like the semantics is slightly different in Zig compared to Odin. And where do people know where this comes from, by the way? Like everyone knows this, right? This is something added to Jai. So that was one of the things, the early things in Jai. Like if you do it like this, then you can like just pass these huge objects, and it's just going to work because you set the parameter to be const. But yeah, I'm not a fan. I don't think that's a thing that you need to optimize for. So I think that the risk here, and it's not a win. It's not a win. to do that. Fortunately, I don't need to think about that because it would be breaking CABI anyway. So it's like, yes, whatever. I don't care. But let's see if I can figure out what the problem is here. So we're going to okay. So every road leads to Jai. Yeah. So it's so funny because like some people on the Sigurd Discord would was claiming that Andrew didn't know about Zeg and like this was his original design and whatever. What? Didn't it use that library? Use did lib. Did I forget what that was? Use did lib. I didn't write that. Oh, I'm setting the settings here to. Oh, still slib. Okay, still lib. Yeah. So everyone was looking at like basically everyone was inspired by Jai. I was inspired by Jai. That's why we went back into language design, and then I was like, yeah, maybe I shouldn't do that. Maybe I should just contribute to something, and then I wanted to contribute to C2, but then C2 didn't take off because this value does not match. So in test here, we don't match that. Why? Because we didn't pick up the those other parameters. So okay, yeah, that makes sense. I remember that I was like looking at that and how can this work? Okay. So where are we? We are in so we're analyzing the optimal returns, right? And up here, and so sometimes we get it from like the declaration turns out it's a function, and then once I analyze that, it's just done. But what we can do now is that we can, like, after we're done now, we can just add those add all or something. Fake add. I thought it had maybe some fake. Okay, for each decal in this. And for every of those, we are going to add that to the list of declarations. That means some of them will be added twice, though. Can't be helped. Back add result decal. Okay, will this work? Or will this cause an infinite loop? Now that worked. So let's run the tested lib. Yeah, anyway, everyone was inspired by Jai. Jai wasn't out. Zeg came out. People were like, yeah, we can contribute to Zeg and so on. Why is this too slow now? Is it broken? It must be broken, right? Like Cogen is broken. Oh wait, did I make? Now it's here. Now it's working. He was like, how could it be so slow now? What's making? Okay, no long functions either. It sounds like, oh wait, did I like 28? What? What? Okay, I'll shelve this stuff. I mean, let me look at that. Did I like suddenly add like a gazillion? Probably. I added some recursive, like the analysis took this long. Okay. Let I think this is bad. Okay, shell changes. Um, if this is bad, what I do is just I end up I throw it away. Um, because then it's something I didn't think about, and it's kind of hard to figure out what exactly was slow. Unfortunately. Still so super slow. What the heck is it spending time doing? What's wrong? What's wrong with my machine? This was not this was not how it used to be. Suddenly I have no like what's wrong? Like look at this bizarre compile time. Like totally bizarre compile times. Like if I just have this hello world, right? Okay. Right, so the analysis took. Okay, this is no standard library, by the way. Shouldn't talk about the like print large functions. Okay. So normally, like, did something go super slow now? So this is normal, right? So I don't know why my computer is so slow. So maybe it's okay. The backup daemon is running. Is that it? Maybe something else is like. Sorry. Yeah, so I don't know what is taking. Sid play still like I don't use it, but it's taking a lot of and I get like sluggish. It's like super sluggish now. So let me just turn off. I think like turn off CLion. Right, but it didn't seem to be that change. So CLion goes down. Right. Let's wake it up again. Okay, sorry. What did you write? Yeah, so started with picking Zig when there are more stable alternatives. It's strange to me. Marketing rules the world, I guess. Yeah, so that is not uncommon, right? We see this with the web every time, right? We are using this new stack, this new this new web framework. We're gonna change the world, and like we are so modern and so on. It's it's a way to signal that you are doing something fresh, right? Rust is also one of those. Like, let's signal that we're doing something fresh. So that gives these languages a boost. Like C3 is definitely not there yet, right? Odin doesn't have that kind of publicity, but either could be like the language people like, "Ooh, we are using this language," and "Ooh, this is going to be like very hyped and stuff." And remember, they kind of need. Why is this so slow? This is super slow. One second to compile this. No, 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 no. Someone should set up like this thing that would compile the entire standard library, or a set of like no standard library, but actually some things that didn't like skip the standard library, but just compiled everything, and just saw that that this wasn't nothing was slow. So remember this, like the numbers here, right? Okay, it's like 290, right? So when I compile this, let's see if I get like probably some random number, like 290, okay, 255. So exactly the same thing, but just again, and 250, and that's this 200, right? Going down. So this is why you kind of need, okay, 200. Still extreme compile times here. So, right. Benchmarking compilers isn't really fair though. Like, yeah, but it doesn't matter. Like you want to, I mean, you want to give a good experience, right? So, like, of course, you like Zig is obviously also cheating by having their stuff extremely cached, and then lazily lazily evaluating things. So they are really, um, like doing what they can to make it fast. C3 is not making that fast yet. So, but I wonder why it's so slow. I'm just going to make sure that the stuff. Okay, so 226. These are insane times, babe. These are insane times. This is not normal. Okay, good. Let's look at the shell changes. Oh, the shell changes. Unshell those. And let's see. So I just don't want any regression. So the reason why you would have like something that would compile the same thing over and over again to kind of form a baseline is that you really want to make sure that you don't have regressions, right? So now we're at 223 here. Again, we shouldn't be doing anything other than doing the analysis. 250. Like, I don't know. 275. It just blows my mind. Do we have a regression? This looks like a big regression to me. Okay, 240. I'm just going to check this out. I'm just going to put this in. Okay, maybe I should just shelve it again. So it's already on the shelf. I can just ignore this, throw it away. Right, roll back everything. And then we have to go back in time. Let's go back to revision, let's say a few days ago, like maybe to further fix differentiate and errors on. Okay, just checking out. No, I didn't. Let's check out this. Show git log maybe. And then we have a bunch of these, so that those didn't pause. But we have something. Okay, so fix this, right? Okay, so we can check out this. So this revision, right? And then just let me check that it's still like the same speed. Otherwise, that's a huge regression. Like usually I would see 100, like twice as slow. So I'm just wondering why it's like. Wait, maybe I'm using like one thing I'm using the debug build. So maybe I should just run the normal thing. To remove the warnings, since those are new. And it's slow. It's still slow. Okay, at least this is not a regression, but my machine is having a regression, I think. I could go back further, actually. But, yeah. Oh, wait. Let's see if I pick. This is so much. 20%. So, I mean, now the backup, now at least it should be faster. 90%. This is something is wrong. Let's go further back. Right. So where can go to? We can go to Git. Again, let's go back in time. Let's go back to here we go. Check out revision. This is a year ago, right? Same things. Sure, smaller standard library. But still, it should be about the same. It compiled differently. Okay. This was a long time ago, so it doesn't. 1 year ago, but a long time. Let's see if we have any version. Also. Look, it's 100 milliseconds. Let's run this again. 77. Let's look at nodes. Okay, we have this, right? And then let's go back to master. Sorry, I'm having a fruit salad. So, going back to this, we're going back to this, and now we are Look at this. Let's compare. Okay, we doubled the size of the Sun library. More than double the number of expressions. So yeah, it's getting very bigger. But I don't know though. Did we really build like the Stan library and make it twice as big as before? Like over this time. So remember these numbers, right? Are we gonna I'm just gonna pull out and just take some of the Stan library, just pull it out. To see if there's something, because it doesn't seem right. Maybe it's right. Okay, we can look at this. So here in the library here, right, we can get somewhere I had number lines of code. Statistic, right? So let's look for that. So see how many C3 lines of C3 you have. Oh, actually, I would like to have this in just the okay, so let's see what we have in the C3 here. So according to this, we have about 100,000 lines of code of C3 right now. And the other one, when I was looking at the old stuff, was that down here, right? So if I check out this one and then do the same statistics, so 100,000 is just 50,000 back then. Or if it's like, if it's 70,000, then we have some macros that are generating too much code unnecessarily. But the good thing though is that we're getting more and more stuff so that we can, so it's easier to optimize this code. Like before we had this much code, it was too, like if you have something that takes like 100 milliseconds, then you can't really see what's taking time. It's not possible. So okay, here we go. It was 80. Okay, look at this. So we added like 30,000 lines of code, but we added like more than twice the number of expressions. Which means that some of these like do excessively much in terms of, so someone's coming here, in terms of code. So it's generating too much. Maybe like there are macros that are called too much or something, but even with that in mind, yeah, that could be it. So like if I look at this now with master, let's see, like I have this idea that maybe, you know, if I remove hash and like this hash one, it and crypto, like if I remove these, so I'm just gonna delete those, and then we run the same thing here. If they are like well, what numbers do we get if we do it like this, right? Not the time in here, but just the okay. Math is using this. Which one is it using? It's using A5 hash, right? So maybe I just remove this and this. No, hash should be in there though, yeah. Can't remove that one. we can remove maybe some of them. Right? So okay, so in crypto we're gonna remove these, which are new, kind of new, and in hash we are removing some of these. So we're gonna add the remove it lake and the comment. I think the ones that are not really used yet. Right. Let's see if I can compile it now. 85 hash. Didn't I keep that around? Oh, okay. So this one should be like that. Close window. Let's see if I had something else that I. Okay, now we're fine. It should be fine. Oh, and let's compile it. Compare this. So not that much, but the number of expressions dropped quite significantly. So there's a lot of there's a lot of expressions in the inlining things happening in the hash, and then they are like what is that? Almost half of all the expressions used in the entire standard library were in those particular hashes, one, the lake 2 and so on. So that could perhaps be a bit optimized, if I say so, because now let's run this again a few times. So what kind of okay? So when we run this, I'm at 100 milliseconds, right? Let's just run this. Of course, this is not optimized, so this is a bit bad. So we can run this on release instead and run without anything. Yes, I mean, there are a lot of checks and certs running, so if we compile without them, it will be a bit different. Okay, let's run this again. Okay, so now we're at 137. 141. Not that fast. And then if we go back and kind of return those cryptos, right? So now everything's back to normal. Oops, I hit the bug, but what? Are we fast again? Like, oh, okay, I know. It's just when I actually run this now with actually optimizations on. Oh, it went up to an 85 there. That's it was down to 90, so it's very volatile this right now. But it does show like we are up to this level because of the number of things in the standard library, basically. And the thing is that that doesn't need to be there, so you can pre-compile a lot of things. So that could be done later, but it's not done yet. But we are down to 1 second in compile times. But it's a bit slow. I think it's slow. Don't think it's got slower as such, but it's there's a lot of code in those hash implementations that actually takes time to analyze. But then we can just look at let's run this profiling thing. So let's see what happens if I run this. I don't think I'm emitting any LVM, but maybe I am. Like, no, I don't emit LVM. Starting, waiting for profile. Okay, whatever. Can I get it to work? Waiting for profiler. Okay, now there you go. Attach. Stop profiling and showing results. So, as usual, though, the LVM is doing the most of the things, which is funny because it's like I actually don't do much. Like it's just doing this hello world, right? So what is it outputting? So we have like the std math, a bunch of that, some ASCII, some dstring, the atomics, I guess, are some of them are implemented, but almost nothing. It's yeah, it's what? What was Blake std hash Blake 3 doing there? What the heck? Blake 3, are you doing something bad? Are you using init? No. Okay. Oh, what? 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 Okay. This should never happen. Why is this done? So CPU info. Like SIMD degree. Why is this? Does it have any other in it? Why run this as startup? That's a bit like why? Okay. Thread. What's it called? Static. What's it called? Thread. Once flag. Once flag. I think that the once flag, if I remember correctly, like it actually works on even on missing if you have no threads. Let's see, thread. What happens with no? So call once, it will just run it. Yeah. So we have a once flag. So flag once. And that one is empty, right? So you do it like. Let me see what I remember exactly now. So once flag. There we go. So okay, basically run once, and then call, and then pick this fn. Doesn't take context if I recall correctly. So it's just like it's local, yeah. So this will be fine. So this. So here we are setting it. We don't need to. We just can set it once, regardless of the number of threads. And someone is interrupting me. Hang on. I'll do a just pause here. Let's see, where actually did I get this? Yeah. Apparently that was nothing. So okay, so now we don't need to do. I don't know if that did anything, but I don't like don't use init instead of in like library in you should never use init in a standard library thing, because it will always it will compile for everyone, for every single person will have that in their code, like totally regardless of what you have. So that was why I was a bit surprised to see it. You shouldn't see that. So now it's gone, right? I don't know. Did someone put some this in it somewhere else? Because you really shouldn't have it. Okay, the Wasm install the signal handlers just for when you have backtrace, right? And there is one thing if you have init exception handler. Okay, so on Windows you do an init on the exception, so you can get the exception handlers. But that's it. So this is better. I don't think it changed anything. It didn't make anything slower, but just I didn't want that. Want to see that. Right. Okay. So let me just continue. I can just continue looking at the at this one. Right. You can still hear me, right? I just didn't suddenly turn off the sound or something. Okay. So you see a lot of things still LVM, and it's just I don't know. We have some things that we maybe can see some better call graphs like methods. Well, we do get a few samples. Like, can we get something that's a big sample? If I merge the callies, like things are. You go, you run the tests, you emit the files. That's going to be like almost all of it still, unfortunately. We are computing callee list. So all this LVM, 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 LVM. Do we have anything with own samples being high? This is high because it's waiting for things, I think. Do we have anything that is related to like C3, LVM, like there are no samples in there. Okay, look at samples instead. Like, did I do anything? No, maybe I just Maybe it's wrong, right? Yeah, sorry. Actually, that's not true. So we can, if I just grab sim analysis run, right? So let's see here. Okay, what did we have? Like where things end up in doing? Okay, Lexer scan token inner. Yeah. What is okay? Get address list. That's something with memory, I think. Scan ident. There's the copying. So the copying seems to happen quite frequently then. So get the macro call is like, okay, well, let's look at samples. So analyzing a function, but analyzing a macro call is grabbing a, is fairly costly, right? Obviously the top level statement is like, this is just going down, right? So we have the top level statement, which is going to be like parsing the globals. Analyzing a statement, yeah, but merge qualities. So we are getting, we have analyzed the stage like 50 between the parse, which is the lexing also, and then the analysis, and then we are getting the most into the function body. Obviously the expression is going to be like the most, and but here look at the macro call, but what is it? Yeah, it's then it's just analyzing the actual the macro call itself. So I could get a reduction. Let's say it's always hard here actually. It's just like this problem with, I don't really see where was like slow in itself, right? I would need more to get like to go. If we look at semi-analyzed statement, right, it's going to be like a lot of those, but own samples where you actually stuck in there, that's the copy expression. And you know, this is kind of interesting though. So check node, cost node check, it will, that's a bit slow, right? So maybe we can look at AST copy deep, that could be made faster, but those are like generally, they shouldn't happen that often. That's maybe you should have like more statistics in seeing what like how often something is running this copy expression, by the, for example, right? Because it will recursively start to copy things. And one thing though, you can just look at this, by the way, like you see the impact of safe and not safe. If we set safe to no, right, we can just look at that, how fast that is. So okay, we just compile for it. Okay, that was actually no meaningful difference. But then we do the checks anyway for the contract. 106, right? So fairly far down. But if someone wants to really dig into what is low, that would be awesome. That would be super awesome. So I think this number here is, it's a bit weird. Like let's look at what we do if I compile the standard library, right? No, the tests, sorry, the tests. And I'm just going to like not print with large functions, and I'm going to have like, I'm not going to emit LVM, so it's going to be faster because of that. We are we are just doing O0. And then the question here is here, like how fast? Okay. Yeah, tests run. So then of course we have a lot of things. We go up to this much time in analysis. We go to 3 seconds to compile the entire this. And the code gen as usual, taking most time. But this, because it's like, I wouldn't like to have like number of lines, but it doesn't really show the number of actual lines after macro expansion, of course. There are ways we could definitely parse in parallel to make it even faster. So what's this? How many? Like 100,000 lines, right? Around 100,000 lines code, not the, no, that's the Zen library, just Zen library, but yeah, I'd like to make this should be faster. This is like a second, it's too slow. Let's commit this thing in Blake here. Just running the test again, just to make sure. So they are pausing. Hopefully I didn't do anything weird with that. Yeah, it's safe. Okay, so now it's time for me to kind of say goodbye. I need to do other stuff. But it's I don't like when it's getting slow. We haven't done anything to make it fast with caching or anything. But I agree with Jonathan Blow, thinking like it should definitely be possible to just do all of this in like compile 1 million lines, right? In 1 second. Now you kind of have I think my analysis before, at least the analysis would do like 700,000 lines in a second, so it's a bit slower, right? But I don't know if I am retaining stuff that should be optimized away. That's I was before I go just let's see, because I had that before, so I was actually running with a lot of asserts that weren't there. So let's add, for example, an assert here. So assert equals 1 equals 2 here, right? And if I run this with release mode, it shouldn't crash. It shouldn't. Oops. Okay, so I'm still running with asserts. Okay, that's good to know. Let's see if why the release is still like building with that. I thought I was running release. CMake release. What does it do? Okay, build type is release. Right. What happens if I do like, okay, I don't do that. It's like if and debug. Maybe I did so and if, okay, and debug. if debug, right? If not, if in def in debug, right? That would be in debug mode. Okay, elif. Okay, so let's look at the asserts, because yeah, maybe I just go to the asserts. Okay, no asserts. What happens if I do like define up here, define no asserts, true. Okay, let's see if it's faster. What? What is that? Okay, so running this in release mode. Printing out a lot of info. That was not faster. Or was it? Maybe it was. No. 366 there. It seems like a bad number. $145. What happens if I turn off the this information, just have 1V, then I can see, then I can't get the stats though. 145. Okay, what now? And up here it's after these 129. And let's get the thing back here with the no asserts. Let's run. So maybe it's okay. Maybe it's okay. Now, oops, that should be like that, because I was testing that it was removing asserts. So finally, let's see what happens if I run like this. Now we should be, I was like at 129, right? So what to say now? $200. So at least these asserts are adding like 200 now, 80 milliseconds almost. What, 80? So, well, almost doubling the compile time. Okay, but that's so no, look, it's down to 149. So maybe it's just a fluke. It's I don't know which ones. It's point. So please, if you have time, if anyone is interested, please set up this, like yeah, those schedulers trolling, right? Set up a something for to time the C3 compiler, how fast it is doing. If you want, that would be awesome. That would be a nice contribution. So okay, but well, I still have this thing that I was working on, so which is this with the contracts. So that will happen eventually. Now it's again, I put back in here. So I'll continue working on that maybe this evening or maybe not. I'll be back very late. So anyway, you thank you for watching. So and have a good evening.